Next problem, if the pair of straight lines represented by ax square plus 2hxy plus by square is equal to 0 and ax square plus 2hxy plus by square plus 2gx plus 2fy is equal to 0, form a rhombus, then prove that a minus b into fg plus h into f square minus g square is equal to 0. So given that the pair of straight lines form a rhombus. So here we have two sets of pair of straight lines, the first equation, second equation. So first we take that the first equation as s is equal to 0. That is, let s is equals to ax square plus 2hxy plus by square is equal to 0. And the second equation is taken as s dash. That is, s dash is equals to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Now what is the given data? The two pair of straight lines form a rhombus. For example, these are the lines represented by the first equation and these are the lines represented by the second equation. So these are the lines represented by the first equation. 1, 2 lines. 1, 2. And these are the lines represented by the second equation. S dash is equal to 0. Now what is the condition in rhombus? The diagonals are perpendicular to each other. Since this is the pair of straight line passing through the horizon, the lines represented by this equation are taken as L1x plus M1y is equal to 0, L2x plus M2y equal to 0. Means the point of intersection is equal to 0, 0. And what is the point of intersection? Represented by the lines of the second equation, hf minus bg by ab minus h square and gh minus af by ab minus h square. That is the point of intersection represented by the lines of the second equation. Means here directly we can find the first diagonal equation by using the point of intersections. Here O is the point of intersection of first two lines and B is the point of intersection of the next two lines. So clearly here directly we can find the first equation by using the point of intersections. So first I take that one. Clearly here point of intersection of 1 and 2 is equal to 0, 0. What are 1, 2? These are the lines represented by the first equation. Here 1 and 2 lines are the lines represented by the first equation, first pair of straight line. That is s is equal to 0. Next, point of intersection of 3 and 4. 3 and 4 means those are the lines which are represented by the second equation. Now this is the second equation. Now what is the point of intersection? hf minus bg by ab minus h square and gh minus af by ab minus h square. Now this is the point of intersection. First point is equals to O and second point is equals to B. Here 3 and 4 are the lines represented by the second equation. Now so here we have the O point and B point, so directly we can find the equation. So for that first I take the slope of OB. Slope of OB is equals to, the formula is y2 minus y1 by x2 minus x1, x1 y1, x2 y2. That is gh minus af by ab minus h square minus 0 by hf minus bg by ab minus h square minus 0. So or directly we can cancel the denominators here, net value gh minus af by hf minus bg. So this is slope of OB. Now what is equation of OB? Equation of OB is y is equals to mx. Since this is the line passing through the horizon, OB means OB passing through horizon. So line is y is equals to mx. That is y is equals to, what is m value here? gh minus af by hf minus bg. This is the first diagonal equation, slope of equation of OB. Now coming to the second equation. Now we have to find the second diagonal. So to find the second diagonal, clearly observe that here this is the second diagonal AC and this is the line which passes through the point of intersection of the s equal to 0 and s dash equal to 0. What are a comma c here? These are nothing but the point of intersection of 2, 4, point of intersection of 1, 3. But what are 1, 3? Lines represented by the first pair of straight line and second pair of straight line. Means this is the line passing through the point of intersections of s equal to 0 and s dash equal to 0. That is, we can take that the equation of this line as s plus lambda s dash equal to 0. S plus lambda s dash equal to 0. So here equation of AC is s plus lambda s dash equal to 0. Since this is the diagonal passing through the point of intersection of s equal to 0 and s dash equal to 0. So we take the equation of AC like that. Now substituting the values of s comma s dash here. What is s value? Ax square plus 2hxy plus by square plus s dash. S dash means second pair of straight line, that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Now what is AC here? AC is the straight line. AC is the straight line means that contains only xy terms, that is a linear equation. So for what values of lambda this represents the linear equation? When we take lambda is equals to minus 1 here, then only this equation becomes the equation of the straight line. When we take lambda is equals to any value other than 1, then what we get? We get one equation in terms of x square y square terms, which is not the equation of the straight line. To get the equation of the straight line means we want only these terms, x term, y term constant. Means we want to remove the terms x square, y square, xy terms from this total equation to get the straight line, since AC is the straight line. For that we substitute lambda is equals to minus 1 in the above equation. If lambda is equals to minus 1, then only the above equation represents a straight line. Then only the above equation represents straight line. Here we want the straight line since AC is the straight line. So we substitute lambda is equals to minus 1 in this equation. Therefore, ax square plus 2hxy plus by square minus 1 into ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Multiplying with minus here, then ax square plus 2hxy plus by square minus ax square minus 2hxy minus by square minus 2gx minus 2fy minus c equal to 0. Therefore, the equation becomes minus 2gx minus 2fy minus c equal to 0. After taking minus cancellation, we get 2gx plus 2fy plus c equal to 0. So this is the equation of AC. Means this is the second diagonal. Therefore, slope of AC is equals to minus a by b minus 2g by 2f is equals to minus g by f. So slope of the one line is equals to minus g by f and slope of the second line is equals to gh minus af by hf minus bg. These are the diagonals. Notice the condition in a rhombus, the two diagonals are perpendicular to each other. So we apply that condition to get the answer. So since given lines form a rhombus, product of the slopes of the diagonals is equals to minus 1. That is slope of AC into slope of OB is equals to minus 1. Now substituting the slopes values. What is slope of AC? Minus g by f into what is slope of OB? GH minus EF by HF minus BG is equals to minus 1. That is taking the cross product here. G into GH minus EF is equals to F into HF minus BG. That is G square H minus A into FG is equals to H into F square minus B into FG. HF square minus B into FG minus G square H plus A into FG is equal to 0. Converting these two terms to this side. That implies taking H common from the first and third terms, that is H into F square minus G square. Now taking FG common from the remaining two terms, FG into A minus B equal to 0. Therefore the answer is A minus B into FG plus H into F square minus G square is equal to 0. Most important condition for the objective problems also. If the equations S is equal to 0 and S dash equal to 0 represents a rhombus, then the condition is A minus B into FG plus H into F square minus G square equals to 0. That's all.